Hello, I am Göksu Günay from Middle East Technical University, Department of Architecture, and this paper forms part of my doctoral research with my advisor Professor Koray Pekeriçli. Our paper covers a literature survey on utilization of decision support systems in construction management. Thus, I'll briefly try to explain concepts about decision making and related practice in the construction industry. As a matter of fact, management is a series of decision-making processes. Historically, good decisions have been identified with experience and wisdom, but today we rely more on facts and data. Computers process huge amounts of data, and information technology is widely used in all industries for data collection, analysis, interpretation, and decision-making processes. In this context, decision support systems are used as computer-based information systems, providing tools for assisting managers in making semi-structured decisions. Information systems help managers to make better decisions. However, construction industry has an intense volume of tacit knowledge, which is mostly transferred as personal experiences from one project to another. Thus, in this paper, we are seeking the answers to the following questions. First, how are decisions made in the construction industry? Second, how effective are decision support systems in the construction industry? There are three key decision-making groups as senior management, middle management, and operational management, with decisions characterized as unstructured, semi-structured, and structured. Structured decisions are the repetitive and routine decisions encountered daily during standard operation of works. Semi-structured decisions are those where only part of the problem has predefined answers. Unstructured decisions are novel, important, and non-routine decisions in which the decision maker uses judgment, evaluation, and insight. Unlike manufacturing industries, construction industry is project-based, where each project is unique and has its own complexities. What works in one project may not work in another. This increases the intensity of tacit knowledge in construction industry, which is characterized as highly personal, hard to formalize, and hard to document, involving a lot of human interpretation. Most important among many roles of a manager are the decisional roles, as justified by Nobel Prize Herbert Simon, who said that a manager must primarily be viewed as a decision maker. Herbert Simon proposed his famous 4 phases for decision making in 1977. These are intelligence, design, choice, and implementation. These phases are interdependent and they supply feedback to each other. Decision support systems can be summarized as interactive software-based systems to help decision makers compile useful information from raw data, documents, personal knowledge, and business models to identify and solve problems to support business and organizational decision-making activities. The advantage of decision support systems is that they can be used by non-technical users and managers for making educated decisions. Although construction is one of the industries that digitalized latest, decision support tools are getting more and more widespread in the industry. Decision support systems are especially helpful where the intuition of unaided human decision maker falls short. Decision support systems can complement human cognitive deficiencies by integrating information sources, enabling intelligent access to relevant knowledge, and supporting the structuring of decisions. Now, we will see 6 examples addressing different aspects of construction. These are risk analysis, design works, tendering, construction logistics, safety monitoring, and negotiating. Risk analysis. A risk assessment tool was developed in this example backed up by case studies with senior managers. Initial questionnaires and interviews showed that professionals mainly relied on their practical experience and personal judgment in risk assessment, even during complicated situations, because they did not want to lose control over the decision-making process. In the research, an assessment methodology was proposed in which risk is modeled as the product of likelihood of occurrence and the impact of the event on project success. During the tests, the participants found the proposed methodology especially useful for analyzing complex and unique projects. Thus, it was concluded that the proposed approach was a viable alternative for assisting risk analysis and decision-making in construction management. Design works. In this example, a BIM interoperable web-based decision support system for vegetated roofing system selection was created, arguing that general design process is derived from the creative process of research, analysis, synthesis, and evaluation, which is very similar to Simon's 4 phases of decision-making. Architectural design process is somewhat different from other disciplines because it is ill-structured, open-ended, and there is no fixed starting point. Still, decision support systems have a great potential for enhancing design processes and increasing quality of design decisions. Results of a post-use interview showed that the tool was found to be useful because it provided a framework or a more structured approach which helped the interviewees to simplify the decision-making processes that were employed. It was concluded that this tool had the potential to improve decision-making and design processes. Tendering. A web-based electronic tendering system was developed in this example for selection of the best contractor. While many countries have introduced electronic tendering systems for transparency and efficiency, tendering processes are still mainly based on paper, which is time-consuming and costly to handle. Besides, most tender analysis products do not specifically address construction tenders. The tool developed in this research is specific to construction contracts. It enables transmission of online documents, analysis and evaluation of tender documents, and selection of the best contractor. The system also supports real-time communication between clients, consultants, and contractors. This tool provides open, competitive, and transparent public procurement by scaling contractors that offer the best value. It is also cost and time effective because when the tenderers input their data to the system, the result is instantly produced. At the end of the study, the tool was tested in a real-world case study, and a web-based survey was conducted to collect opinions, comments, and suggestions from the users to test the applicability of the web-based decision support system. The participants gave high scores to the tool in utility and efficiency criteria, and it was also considered as user-friendly. Construction logistics. In this example, a GIS-based set of decision support systems was proposed for improving construction logistics and supply chain to be used by public and private decision makers. This tool helps to understand, quantify, and compare the impacts of policy and optimization measures on the delivery of building materials on construction sites. Restrictions on size and emission standards of delivery vehicles are addressed as well, where the user can quantify the impact of restricting the size of vehicles. Internet of Things sensors on vehicles, infrastructure and goods enable capturing of real-time data, including traffic data, track movements, or movement of goods at low costs. In this way, urban freight transport can be improved and effective transport strategies can be developed. It was argued that impact of transport is generally underestimated during planning phase, and transport and logistics issues are usually addressed during the execution phase. Addressing these earlier in the planning phase would have positive impacts with regards to accidents, congestion, noise, and pollution. Simulations for this example produced very good results. Construction workers' safety monitoring. This research was based on the concern that fatigue prediction could be vital since high fatigue level means increased risk of accidents. Fuzzy logic was used in this example to mimic human reasoning because assessment, evaluation, and decision-making related to safety of construction workers are not easy to quantify, and they require qualitative human expertise. Fuzzy logic minimized the disadvantages of qualitative approach when there is subjectivity, doubt, and expert judgment. The researchers used real-time measurable indicators such as heart rate, body temperature, muscle activity, and working space temperature for fatigue prediction. Workers' characteristics such as age, height, weight, lifestyle, and workload were considered as well. When the system was tested, it was observed that performance classification through fuzzy reasoning worked well. Thus, the output was concluded to be useful in producing recommendations related to worker safety conditions before and during work. The system could be further improved as an early warning system by combining software and hardware to be carried on workers. Negotiating. In construction projects, negotiation is indispensable for a harmonious relationship between the parties involved. However, it is also time and energy consuming. It is a decision-making process in which two or more parties seek to reach a consensus and complex technical and human issues are addressed. Decision support systems addressing negotiation processes are mostly based on game theory applications, and the last example to be given in this paper covers methodologies for conflict resolution in construction projects using non-zero-sum games with fuzzy payoffs. In this model, it was argued that it is difficult to assess the payoff when game theory is applied to real-world problems such as decision-making. However, it would be reasonable to model the problems as games with fuzzy payoffs. Thus, two fuzzy matrix games were proposed to resolve disputes between the owner and the contractor. Applicability and efficiency of the fuzzy games were tested on a large oil project in the Persian Gulf, and an equilibrium status was achieved for different preferences of the parties. Optimal mixed strategies could be provided by the fuzzy games in the negotiations between the owner and the contractor, which showed that proposed games could be effectively utilized for incorporating the existing uncertainties. Thus, the fuzzy games could be applied to more complicated contractual or constructional conflicts. Although decision support tools are getting more common in the construction industry, many authors point at the inefficiency of most of them as they lack the experience and intuition used by human experts. It is argued that using decision support systems for real-world challenges is still in the early stage of development, and practical use has been limited. Professionals still rely on gut feeling and subjective judgment in decision-making, and as a matter of fact, human beings do not always follow the rational path. Considering the examples studied in this paper, it was observed that decision support systems had greater potential in certain areas, such as design and tendering, but they fell somewhat short in risk analysis and negotiation processes, where human judgment still seems more preponderant. Decision support tools within the construction industry should be dynamic models based on learning systems which can process both objective and subjective information. On the other hand, advances in intelligent technologies are enhancing decision support systems for the construction industry as well. Technologies such as sensor networks, the Internet of Things, and artificial intelligence applications like fuzzy logic, machine learning, natural language processing are providing powerful tools. Therefore, in parallel to these developments, decision support systems may be expected to be more prevalent in the construction industry soon. This is all I have to say. Thank you for listening.